I want to talk about the week 4 discussion. And remember that when you're on your homepage, uh, it's real important that you uh, always you start your week by reading the announcements. Okay, so there's new announcements every week. And sometimes students skip those and then they jump right into the assignments and they do things wrong. They do things they're not supposed to do, and then they have to redo them. And so when there are changes, and again, there are on the discussions, you need to look here. So you'll see week 4, there's a revised discussion as all of the weeks. So uh, you want to make sure you go into um, doc sharing, right, to get that week 4 discussion. That's you open that file up and then follow those. And we're going to do that in just a minute. And so let's go ahead and open that file up. So this is the one again that's in doc sharing. That's the one you have to do to get any credit for it. And so this one, week 4 on hypothesis testing, and there's lots of different types of hypothesis tests. And it says here, statistical hypothesis is a claim about a population parameter. So this test, hypothesis testing one sample mean, um, this says one sample, but they're saying it's a claim about a population. Basically, what that means is you're going to collect one sample of data and compare your results or your sample mean to the population mean. Okay. And then you're going to do another test, and you see this is a one sample proportion hypothesis test, and you're going to go out and collect one sample of data and compare that sample proportion to the population proportion. And that's what we're going to be talking about here in this discussion. So again, to prepare, it says, review the week 4 discussion resources. Now we need claims for population mean, population proportion. So you need two, you're going to do 2 separate tests. You need 2 claims. And, students say, well, I don't know, they'll make something up and say, well, people on average are 70 inches tall. Well, you can't make up the population parameter. You have to find it. Okay, so it has to be legitimate. It's nothing again that you just make up or what you think it is. So you're just gonna go on the internet here and say, for example, let's put in here average blood pressure. And the difference between just some claim or whatever or some population parameters, we have lots and lots and lots of data based on lots of studies and data collection and so on. And we pretty much know right here what this says. So it's very easy. Normal blood pressure in adults is blood pressure. And again, we say basically a 120 over 80. So that's good enough. And it's not exactly that, but that's fine. We just need to know because it doesn't have to be exactly, but we're just saying on average, we're going to say, it should be basically like 120 over 80. So we really only need the top number, the systolic, for this particular example. And then you could go in and look at proportion. Again, you can go online and like I did in my example, and if you go down here for a minute, you'll see I looked online and found the National Institute of Health states that 50% of people over 45 have cholesterol deposits in their arteries. That's a proportion, okay? Again, 50%. So you're going to be looking up and trying to find a percent. So that's a qualitative variable because either you have cholesterol deposits or you don't. Okay, it's not numeric because there's a 50% here or 45, or you have a bunch of numbers. The variable, again, is the idea of whether you have cholesterol deposits or not. Okay, so that's qualitative. What we did up here, we talked about the systolic blood pressure. We found it was 120. That's quantitative because we measure blood pressure with a device and it comes out to be some number, right? It's not like a yes or no answer or a non-numeric answer. So we have a quantitative variable and a qualitative variable, and we're learning to do a hypothesis test on either kind, right? We're going to do both. So you need to get some data. And again, the one thing is the data is not important. If you can't find listed data or something, that's fine. You can't make up the claim. You can make up the data. Again, because the data is not of interest in what we're doing this week. We're trying to understand what is statistical hypothesis testing. Okay, so you get those claims, and we need to put the data into StatDisk. Now, the one thing that this says here is in StatDisk, it doesn't take and work with words very well. Like we could have put in yeses and nos. So for this example, I used the number 1 for yes and 0 is a no, okay, when we go into StatDisk. All right, so it says run a hypothesis test for both variables. We got 2 variables, again, quantitative, that's the test of the means, and you have a proportions test, so that's the qualitative test. We're going to do these separately. And here's my 2 columns of data. Of course, this is numeric. This is my quantitative data. And this is non-numeric, or it's not a coded variable right now, but it will be numeric. But it's really standing for yeses and nos. Okay, so that's what we were saying up here. We're using, ones instead of yes, zeros instead of no. So the variable, again, is qualitative. And then we're going to put this in a StatDisk and then run the tests. And then we're going to come up with a conclusion about what we found there, okay? So let's go ahead and see if we can get StatDisk up here online. Let's see, it is, there it is. All right, so again, I just need to squeeze it in a little bit and see if this will stay. Now, we're going to put these data values in column 1. So I'm just going to copy, Control C, and Control V. I'm on a PC, so remember that on a Mac it's Command C, Command V. And so I got those data values in, and there were 15. Okay, so we have 15 data values. And then I need these ones, the hardening of the artery. And you'll see, I'm just going to copy this over here. Control C, Control V. Now, remember I said that StatDisk doesn't like letters. So these Y's, you'll see I'm going to change those into 1s, right? So we're going to make those 1s. And then the nose. And 1. Okay, and that's going to be a no. 0. Yes. No. And yes. And 1 and 0. Okay, so I changed those all over in StatDisk. So you see my second column. And that's going to allow us to do a couple things with that. First, we're going to run the means test over here. So the one sample mean test, we need to get the descriptive statistics here. Okay, now I'm not going to do all the exact numbers. Again, this is your discussion, so I'm not going to do it all for you. But what I want to show you though is I need to know the mean and standard deviation of this column of numbers. So data, all right, and then descriptive statistics for column 1. Remember that we did that before, one of the other projects. So here's my histogram. I need that. I don't need those. And then there's my mean, and there's my standard deviation. So you're going to have to write those down, put them in a table, and that's it. Okay. So again, I'm going to make up these numbers as I go. So once I get this, I go to analysis, hypothesis testing, mean one sample. All right, so the StatDisk program writes alternative hypothesis, but we're supposed to list both here. So run a hypothesis test for both variables in your table, hypotheses for the means test. The null hypothesis is that the mean systolic blood pressure for a healthy adult is equal to 120. So there's our null. Alternative hypothesis is that the mean systolic blood pressure for a healthy adult is not equal to 120. So alternative, it says population mean not equal to the claimed mean. So that's what we were just saying, not equal to. So this is on this first one. There's 3 options, okay? All we're doing is running a 2-tailed test. Not going to do right or left-tailed test in the discussion or the project. Okay, we need a lot more time to talk about all that stuff. But so this is set up for the 2-tailed test. Not equal to. That's the alternative. Significance level is 5%. Okay, so we got that in there. And then the claimed mean. Again, I'm making this up. I'm going to say the claimed mean was, in fact, let's leave it at 100. We'll say 100. Right. Now, population standard deviation, you don't know. Nobody's going to know that. We, are talking about a one sample. That doesn't tell us what the population standard deviation. Okay, sample size, I'm going to say 50. Again, yours isn't. That's just making that up. Sample mean, I'm going to say my sample mean was 144. My systolic blood pressure for the 50 people I talked to averaged out to be 144. So that's a little bit high. Sample standard deviation, I'm going to say it was 17. Again, guessing. Just you're going to put in your numbers here. Evaluate. And so this is the hypothesis testing up, but you can copy all of this and put it into your discussion, okay? And what I came up with here, the important thing is the p-value. The one thing to remember is at the end, write a conclusion based on your comparison of the p-value and the level of significance, okay? So the p-value and the level of significance, which is right here, okay? Your conclusion is to accept or reject the null hypothesis. So if the p-value is less than the significance level, you reject the null hypothesis. Okay. In other words, you accept. I'll say that one more time. If the p-value, this one is 0, it's less than this number right here, that means we reject the null hypothesis. Okay. So that's my conclusion. Okay. So that's my one sample means test. And I'm going to go back to my data. Here it is, sample toggle my editor. And we're going to go through basically the same thing that we just did, but with proportion. That's column 2. I need my descriptive statistics for column 2. Okay. Now, these are proportions. 5 out of the 15, because there's n equal 15, 5 out of 15 were zeros, which meant no's. 5 of those people were no, they didn't have any cholesterol in the arteries. 10 of the people, we'll see this bar, well, they represented a 1, so that means we had 10 yeses and 5 no's. Okay. And you'll see that this output basically is because we have numeric values, but we only need the sample size and the proportion, okay, or the number that we're looking for. So let's go to the test, analysis, hypothesis test, proportion 1 sample. Okay, again, alternative hypothesis. Now, the null hypothesis is that 50% of the people had hardening of the arteries. That was our null hypothesis. The alternative is that it's not equal to 50%, or population proportion not equal to 50%. So again, alternative not equal to. Then we got to put in our significance level, again 5%, that's for both tests. Claimed proportion was 50%, right? 0.5. Sample size was 15. I'm going to plug these numbers in because this isn't going to be your example. And then number of successes, 10 people, right, had hardening of the, yes, they had cholesterol in the arteries. I'm going to click evaluate, and you'll see sample proportion, that's 10 out of 15, was 67%. If we round that, we get this test statistic, which again, we don't really talk about in the discussion, and critical value. These two numbers, test statistic and critical value, are the same thing as the p-value and the significance level. They're different units of measure. But look at my p-value. P-value is like almost 20%. Is that less than the significance level? No. So we fail to reject the null hypothesis. Okay, we accept the null hypothesis that roughly 50% of the people, right, we don't have enough of evidence to dispute or reject that claim. We would have had a p-value, had to be less than 5%. That's the only time we're going to reject. Okay, so that's about it. And again, remember to follow the directions. And you have any questions, let me know.